Good night. Today we talk about Phytoplankton as a bioindicator in lentic ecosystem in University of Cundinamarca Environmental Engineering.
Bioindicators are living organisms of animal, fungal, and plant origin, used for the identification and quantitative determination of environmental pollutants generated by humans due to their sensitive concerning all the issues in the environment, being this capable of respond, respond, responding to physiologic variations and effects of pollutants, making known the extinct rex reacts to the possible effect that this will find on the ecosystem. Acute, terrestrial, and aerial.
The ecological role of phytoplankton is fundamental since it regulates energy access to the system and constituting the base of the trophic pyramid. In this way, its study helps to obtain more precise and descriptive information of water quality through a hydrochemical study. For these reasons, it's considered a good bioindicator of the ecological state of pollution in lakes, rivers, and wetlands. Its analysis became an essential part of any project of ecological characterization of low water mass since they are mainly in the column of water and don't have great mobility on their own being subject to change in the current. Given this, they are considered suitable for stopping and monitoring physical chemical pressure related to eutrophication, water mineralization, and thermal pollution.
For many, it may come as a surprise, but the truth is that most of the annual oxygen production on our planet, between 50% and 85%, does not come from terrestrial forests, but the ocean phytoplankton, set of millions of microorganisms that are present in the waters that surround the five continents, is responsible for carrying out a photosynthetic process in which it is estimated that about 10 gigatons of carbon from the atmosphere are buried in the depths of the ocean area. Around 80% of the phytoplankton bowl will correspond to the atoms Basilorophyta, which are microscopic unicellular algae that can be found floating freely in the water or arrayed to some substrate.
Diatoms are a group of unicellular eukaryotic microalgae. These microorganisms have a size range that fluctuates between 15 and 500 microplankton. They are extremely aerotrophic. They present photosynthetic pigments such as chlorophyll. A special feature of this type of algae is that they are surrounded by a unique cell wall made of silica, hydrated silicon dioxide called a threshold. They have been widely used to determine the state of conservation of the lakes. One of their main characteristics is that these species have different levels of tolerance to nutrient concentrations and that they have short life cycles. That is, they reproduce very quick, so they can respond quick to the environmental conditions present in lakes, rivers, and even in masses.
Organic matter. Pollution by biodegradable or not biodegradable organic matter in the water sources from domestic and industrial. Switch discharges cause a deficit of dissolved oxygen, DO. In the degradation process, all the DO is consumed, reducing the capacity of autopurification of a tributary. As a consequence, there is a loss of biodiversity, forming typical putrefaction compost and at the same time generating accumulation in animal tissues as toxicity increases. Although organic suspended solute are biodegradable through hydrolysis, soluble organic consumers are commonly considered to be solid organic consumers of the wastewater water are mainly composed of protein 40 to 60%, carbohydrates 20 to 50%, lipids approximately 10%.
General objective. Describe the dynamics of phytoplankton as a scientific bioindicator to environmental alterations. Specific objectives. Number one, consider the changes in phytoplanktonic biomass related to anthropogenic factors and their environmental consequences. Number two, identify the abundance is and distribution of phytoplankton at the sampling points to determine the alterations in its structure due to the pollutant.
Methodology. A slot water source was selected in which 2 points were selected. The first sample point is located in the upper course and the second at the end of it. The specific size that were monitored were selected according to the ecological relevance and accessibility of the plankton. Two methods were used. The first with a server network designed to obtain quantitative samples. It consists of a metal frame to which a nylon net is attached. The frame with a determined measure 30 for 30 cm serves to delimit the sampling area and to calculate the index of diversity and species range about unit of surface.
The frame was placed on the substrate and with the hands the material was removed within the frame area. The plankton was trapped in the net place upstream. The second methodology was taking running water with a simple container without a net, qualitative method, used for the general determination of the presence of genera and species of plant.
In situ sampling of the physicochemical aspect of the water were carried out at each of the points using an oxygen meter. Measure the percent of oxygen saturation in the water and its concentration. A multiparameter to measure the pH, conductivity, ability or power conducing or transmitting here electricity or some water. And total suspended solid points suspended in the water samples because they are insoluble and thermometer.
To determine the quantitative concentration of phytoplankton, the following formula was used, where an equal number of cells in the sample, X, equal to total number of cells in the chamber, A, equal chamber area, B, equal volume of sample settled in the chamber, A, equal area of the optical field or grid. To find the biodiversity index, the following formula can be used. The quantification of the species diversity is essential to determine the abundance and distributions of the species, where the existing contaminant can produce alterations in the structure of the community. Simpson index quantitatively determines the biodiversity in a delimited area. The number of species present in the habitat must be taken into account, as well as the abundance of each species, where V equal Simpson index and lowercase equal total number of organisms of a species, and capital letter equal total number of organisms of all species.
Shannon index. This index reflects the heterogeneity because it is related between temporal and spatial variation in the environment. The restrictions imposed in some way on the organisms, as well as their response of the restrictions of a community, be used on two important factors: double that number of species present and their relative abundance. The above calculations are essential to determine the degree of impact on the aquatic environment.
The BOD is the biochemical oxygen demand that water has. Is the amount of oxygen that microorganisms, especially bacteria, aerobic or anaerobic, fungi, and plankton, consume during the degradation of the organic substance contained in the sample. It's used to measure the degree of contamination and is expressed mgO2/L.